All right, with number 5, we're going to graph this one with transformations as well. The thing to be careful of is that you want to kind of work this as order of operations. You want to work inside parentheses and work your way out. And then this is going to be the last thing we do. So in parentheses, right now we have a log of 1/3. Okay, so I'm just going to do this in phases. So right now that 1/3 tells me that my graph is coming down from the top and curving this way. That's the first thing that's happening, 1/3. In parentheses with the +5, +5, it does the opposite. You would think it would move it right 5, but it's actually going to move it left 5. So 1, 2, 3, 4, 5. So here's my new image. This graph got shifted to the left 5 units and it's still coming down going that way. So that's just the first part, the original and then the horizontal shift. Now we have a negative out front of our log. So we got this negative. This is going to affect the y value. So think, if y was positive and now it's negative, it's going to get flipped. So this graph is going to get flipped. So when you apply the negative, what happens is all of a sudden now this graph looks like the original graph is going up. But you also had that shift. 1, 2, 3, 4, 5. So that's negative. This should be crossing at -4, 0 right now. So it's going to be going up and crossing and going this way. Because of that negative, it's going to flip it. And then you got that +5. +5 is going to shift it up. 1, 2, 3, 4, 5. So this graph is going to be crossing at -4, 5 and curving up this way. So that's what I'm going to be looking for on the graph. This one almost looks, let me see, 1, 2, 3, 4, 5. That looks perfect. And do any others come close? What about this one? 1, 2, 3, 4, 5. But this is on -1, -2. That's -3. So that one didn't go over enough. This is the one we're going to look for: -1, -2, -3, -4, and then you go up 5. So that's that point that I've been kind of following. I usually just follow that ordered pair, and then however it was shifted or translated, I do that to it. So this is the graph we're looking for here. And then here we're going to change gears and we're going to find the domain. So remember, in the beginning, we're going to talk about domain. All you do is set whatever is being evaluated inside of the log greater than 0. So in this one we have a natural log, and it doesn't matter, they all perform the same. Natural log x minus 1. So your base is understood to be an e, is irrelevant. You only focus on what's inside the parentheses being evaluated. So for your domain, you take the x minus 1 and say it has to be positive, has to be greater than 0. Solve for x, so you would add 1 because it's -1. That will cancel, and that will give you x is greater than 1. So your domain is x has to be greater than 1. They want it in interval form, so you will say 1, comma, to positive infinity. So any number between 1 and infinity that you plug in will come out positive. So I'm going to put parentheses 1, comma, and then get my keypad and do infinity.